Good day, students. So in this clip, we're going to be going over some examples on how to find one and double-sided limits graphically. So we're going to be using this graph right here to do the examples. All right. So what I'm going to do first is let's label this graph. I'm going to call this graph y equals f of x. All right. So before I start the examples, let's go over some rules about double-sided limit and one-sided limit. So if the left-hand limit of any function, so let's say as x approaches a from the left of f of x, if let me move this down a little bit so that I have enough space. Alright, so if the left hand limit is equal to the right hand limit as x approaches a from the right, then whatever that value is going to be exactly equal to what the limit of x is as it approaches a from both sides. Okay, so the left hand limit and the right hand limit are equal. That is what the double-sided limit will be. All right, but if the left hand limit as x approaches a from the left of the function is not equal to the right hand limit, which is the limit as x approaches a from the right of the function, if you have this scenario, then the double-sided limit as x approaches a without any sign means from both sides of the function does not exist. Okay, so just keep this fact in mind when we're finding the limit of this function as x approaches different values. All right. Okay, so with that in mind, now let's go over the following examples. First, what we're going to do, we're going to find, we're going to do three at a time, okay? So for A, let me label them 1, 2, 3. So for number 1, we're going to try to find a limit as x approaches -6 from the left of the function f of x. And then we're then going to find the limit as x approaches -6 from the right. And then we'll find the double-sided limit, which is the limit as x approaches -6 without any sign means from both sides. Okay. All right, let's do the first one. Limit as x approaches -6 from the left. You notice that we're focusing on energy in this area right here. And if you notice, we have an infinite type of discontinuity here. So the question is, as x is approaching -6 from the left side, as x approaching -6 from the left, what is happening to the y value? Okay, what is happening to the y value? So one way we can look at it, so this is what we're approaching, is think of driving. Okay, you're driving down this curve. If you're driving along this curve, as x gets closer and closer to 6, what is happening? You're either going to be increasing, increasing, decreasing, or you're staying at a constant. But what's happening here? You notice that as x is getting closer and closer to -6, and you're on a car driving here, what is happening? You notice that you're going down, you're decreasing. All right, so in this case, you're decreasing. But as you get really, really close to -6, what limiting value are you approaching as you keep decreasing? Since you have a discontinuity here, you're guaranteed to keep going down and down forever. Since this graph has an asymptote here, you're guaranteed to keep going down forever. So if you go down forever, what's that value? That value is basically negative infinity. All right? So remember, anytime you're doing limits, you're either going to be increasing, decreasing, or staying constant. If you're increasing or decreasing, it's either to a value or to infinity or negative infinity. All right, so in this case, it goes all the way down to negative infinity. All right, how about the right-sided limit? What if x, for number 2, is approaching -6 from the right? So this is -6 from the right. So as x is approaching -6 from the right, we're going to jump to this curve right here. Okay, so in this curve, let's say you're driving down in this direction, what's going to happen? Are you increasing, decreasing, or staying constant? As x gets closer and closer, going that direction, that means your car is going to be facing here. What is happening? Your car is going to be going where? Down. Okay? So it's going to be decreasing. Your y value is going to be decreasing. So how low are you going to go as you get infinitely close to -6 without approaching it? Since you have an asymptote here, You're going to keep going down and down and down forever. Alright, so you're going to be approaching negative infinity. So the right-handed limit here is also going to be negative infinity. Alright? So what is the double-sided limit going to be? Well, when you have infinity, it's kind of hard to quantify what numbers these are because it's not fixed numbers. Since you have negative infinity and negative infinity here, these are not finite numbers, the limit, the double-sided limit, does not exist. Okay? Alright. I hope you see here, these are not fixed numbers, these are arbitrary numbers. There's no fixed number known as infinity. So since these are negative infinity, that's why the limit does not exist. Alright, let's move on to 4, 5, 6. So for example, 4, 5, 6, we're going to be looking at the limit. So number 4, the limit as x approaches negative 2 from the left of the function. And then 5, the limit, we're going to try and find limit as x approaches negative 2 from the right. And then, lastly, we'll try and find the double-sided limit, the limit as x approaches negative 2 from both sides. So we don't have any signs above the 2, that means it's double-sided. Alright, so now let's take a look at approaching negative 2 from the left. So as x approaches negative 2 from the left, imagine this is what we're approaching right here. We're approaching this value. So imagine that you're in a car. If you're in a car driving along this curve, you see the direction of your car. Since we're going towards negative 2 from the left, your car is going to be facing here, right? So as your car is driving towards here on the curve, what's going to be happening? You notice that you're what? You're increasing. The y value is increasing, all right? So as you get arbitrarily close to this fixed value, how high do you go? You notice there's no discontinuity here as, there's no infinite discontinuity here, sorry, as we did in example 1, 2, and 3. It's actually a removable discontinuity. So in this case, you're actually approaching the specific y value, and that y value right here is this y value between negative 1 and 1, which is 0. So as x approaches negative 2 from the left, you keep going up and up. The y value that you keep approaching is 0. Alright, so the left-handed limit is 0. Now what about the right-handed limit? Alright, the direction of the limit will tell us what direction we're driving on. Okay, so if we're going to 2 from the right, like this, we're approaching 2, that means our car is going to be facing the left area, right? So if we're driving a car on this curve, and as we're getting closer and closer to 2, what's going to be happening with our car? You notice that we're going to be coming down, right? So we're going to be decreasing. The value is going to be decreasing as you get arbitrarily close to negative 2. So since your car is facing this direction and you're going down and down, does it go down forever or does it have approach a specific value? You notice we do not have an infinite discontinuity here, so it's approaching a specific y value, which is right here. So what y value is it approaching right here? The y value is between 1 and negative 1, which is also 0. Okay? So it's getting low and low, and the limiting value is 0. So the limit of the function as x gets really close to negative 2 from the right is 0. Alright? So what's the double-sided limit? What's the double-sided limit? So since these two numbers are fixed numbers and they're the same, so the double-sided limit is 0. So what this basically means is when you're approaching negative 2 from the left or the right, you're going to be approaching the same y value, which is namely 0. Right? You see from the top, you're approaching 0. From the bottom, you're approaching 0 also. So this is the value that you're approaching right there. Alright, now let's try 3 more examples, and that'll be that. Let's take a look at the, there's too much. Let's take a look at the limit as x is approaching positive 2 in this case. Okay, so x is going to be approaching positive 2. Erase the whole thing. 7, 8, 9. So for number 7, we're going to try and find the limit as x approaches 2 from the left. Number 8, we're going to try and find the limit as x approaches 2 from the right. And then number 9, we're going to attempt to find a double-sided limit. Limit is x approaches 2. No sign means double-sided, okay? Alright, so let's do the left direction. So When you're approaching 2 from the left, when x is approaching 2 from the left side like this, alright, we're on a car going down this curve. What direction, what's happening with your y value? Okay, as you're getting really, really close to 2, and you're on a car driving down this curve, your car is going to be facing here. You notice you're going to be decreasing, right? Your y value is decreasing. Does it decrease forever or towards a fixed point? You notice that when you're going low and low, you have a fixed point that you're approaching here. It's not actually um, an infinite discontinuity. So it's actually approaching -4. Alright, so the left-handed limit, as x approaches 2 from the left, your y value is getting low, and really close to -4. So your left-handed limit is -4. How about if you're approaching 2 from the right? If you're approaching 2 from the right, you notice that you're on a different function, this function right here. And this is a constant function, okay? So as you get closer and closer to 2 from the right side, this is your car right here, what y value is it approaching? Guess what? The y value is constant in this case. So it is neither going up nor down. It stays at the same constant y value regardless of where x is going. So as x gets really, really close to 2, y stays fixed at 1. Alright, so your right-handed limit of the function is 1. Alright, so now since the left-handed limit and the right-handed limit are different, the double-sided limit does not exist. Okay, so there you have it. Thanks so much for paying attention to this presentation. You can feel free to subscribe to my videos and like it here if you liked it. And you can find a collection of my clips on mathgotserved.com. Thanks so much and have a wonderful day.